Okay, question 8 of the 2023 General Math exam. The final question in that exam is a question from the discrete models topic. You can see there's a precedence network drawn here, which appears to have a forward and backward scan complete, giving us a minimum completion time of 83. But there are no times associated with those individual tasks that make up this project. The network itself shows the task to be completed so that students on a camp can start their hike, and the times taken, T for completing tasks, are in minutes, where T is greater than 0 minutes. So, first of all, when we look at a network, it's made up of, in this case, it's a directed network made up of arcs and nodes. So each arc represents a task. So for example, this arc here, the arrow represents task A, and within the node, that represents the finish, in this case, of task A and the start of task B. The two numbers inside that node on the left-hand side represents the earliest starting time for the task that follows the node, and on the right-hand side, the latest start time for the task that follows the node. So for example, if I'm looking at this node here, okay, the earliest starting time for task K, which follows this node, is 43 minutes, and the latest starting time for task K is 51 minutes, okay? Now, if the values inside the nodes for the earliest starting time and latest starting time are the same, it indicates there is no slack time, meaning that that is part of the critical path. Now, there are two critical paths here. The first one, if we follow those nodes that have the same values from the start, is along task A, B, E, H, and L. And the second critical path is along tasks C, D, E, H, and L. So all of those tasks are critical tasks. Now, we want to identify the time taken to complete each of the individual tasks within this network. So let's start there. Task A. Now, task A, from the start to the finish of task A is 5 minutes, so it obviously takes 5 minutes. For task C, starting at 0 and finishing in 10 minutes obviously takes 10 minutes. Now for tasks B and D, it's a little bit different, but because both are on the critical path that we just showed there, the difference between the latest start time here, 22, and the latest start time here, 5, will indicate how long task B takes. So that's obviously 22 take 5 is 17. And likewise for task D, it's the difference between 22 and 10, which is 12. Now for task E, the earliest it can start is 22 minutes, and the earliest task H can start is 37 minutes. So task E is 37, take 22, 15 minutes. Task F, the difference is between 43 and 22, which is 21. Task G is a little bit more difficult because task F and G are not on either of those critical paths that we identified. And this dummy link here represents that F is also a prerequisite of task J, which actually means that we don't have enough information to work out how long task G takes, okay? This dummy link, remember, has a weight of 0, and the 43 is the same here as it is here. Task G could potentially be the difference between 43 and 22, which is 21. It certainly can't be any longer than 21 minutes, but there's not enough information there. It could be less than 20 minutes, could be 15, 16, we don't know. So I'm just going to put a question mark there for task G. We're not sure how long that takes. For task H, okay, we're looking at the difference between 69 and 37, okay, which gives us 32 minutes. And for task K, we're looking at the difference between 69 and 51, which is 18 minutes. And for task L, we're looking at the difference between 83 and 69, which is obviously 14 minutes. And for task J, we're looking at the difference between 83 and 72, which is 11 minutes. Now, the latest start time is indicated on the right-hand side of each of the nodes for each of the tasks, apart from where more than one arc converges back to a node. So for example, I'm talking about this node here, which has tasks E, F, and G backing onto it. Now we actually can't work out that latest start time for task G because we don't know how long it takes. Task E has a latest start time of 22 because it was on the critical path, and 37 take 15 is 22. But for task F, 51 take 21 is not 22. It's actually 30. So the latest start time for task F is 30 minutes. So I'm going to use a different color and put that in on the arc near the node that represents the beginning of task F to show that, although task E has a later start time of 22 minutes, task F has a later start time of 30 minutes. So you could potentially delay that a little bit before you start it. It's not going to impact that minimum completion time because it is not a critical task. It is not on the critical path. All right, that's all the information we can put in. Like I said, we can't work out that later start time for task G, so I'm going to put a little question mark there as well. Moving on to the first actual question, because you're not getting any marks for what we just did there, but that will help us obviously along the way. State the time taken to complete task C. Now we've done that working out. Task C takes 10 minutes. Okay, moving on to the next part of the question. It says to tick the correct box to complete the statement below. The total time taken to complete tasks A and B is shorter than the total time taken to complete tasks C and D, longer than the total time taken to complete tasks C and D, or the same as the total time taken to complete tasks C and D. Now, A and B, which is 15 and 17 minutes respectively, 5 and 17 minutes respectively, gives us obviously 22 minutes. And tasks C and D respectively are 10 and 12 minutes. Okay, so 10 plus 12 is also 22. So the correct answer is that third box. Task A and B take the same total time to complete as tasks C and D. Now, state the time taken to complete task K. We've got that there. It's already input into our precedence network, 18 minutes. Pretty straightforward now that we've done that working out. The last question on this page is to state the latest starting time for task F. Now, remember, we did that as well. It's that little 30 that we put up against that node. So it's the difference between 51 and 21 to give us that latest start time for task F. So 51 take 21 is 30, which means the latest starting time for task F is not actually 22 minutes, it's 30 minutes. So the working out, if you want to show it, is 51 take 21, which gives us 30 minutes. All right, moving on to the next page. Which of the following tasks has a greatest slack time? Tick the appropriate box to indicate your answer. Now remember, the slack time is the difference between the latest starting time and the earliest starting time. Okay, that will give us our slack time. So for task D, the slack time is shown here in this precedence network. It's 10 take 10, which is 0. For task F, okay, remember the latest start time for task F, we just identified it was 30. So it's 30 take 22, which is 8. For task K, we're looking at 51 take 43, which is also 8. And for task J, we're looking at 72 take 43, which is 29. So for task J, 72 take 43, which is 29. So the task with the longest slack time is task J. Means you can delay task J up to 29 minutes and it won't impact the minimum completion time then. Now, part E, the time taken to complete task G cannot be calculated from the network diagram. Yeah, we knew that from that little dummy link there. Complete the following statement. Task G will take more than blank minutes, but at most blank minutes to complete. Now, we kind of spoke about that already, didn't we? So obviously it's going to take more than 0 minutes because it needs to be more than 0 minutes. It can't be done in less than. So task G will take more than 0 minutes. but at most how many minutes to complete. Now, basically we're looking here at the difference between this 22 and this 43. All right, so what is the difference between the 22 and the 43? Well, 43 take 22, it's 21. So it cannot take more than 21 minutes. Okay, part FI. There are two critical paths within this network. It says to state all tasks that are critical within the network. So if I highlight those two different tasks, I know I kind of drew over them to start with, but two critical paths were A, B, E, H, and L, indicated by obviously those nodes that have the same earlier start time and later start time. And the other critical path was along task C, D, E, H, and L. Now, it's not saying to list the two critical paths, it's just saying to state all tasks that are critical within the network. So we're talking about tasks A, B, C, D, E, H, and L. And they're critical because they obviously we cannot delay any of these tasks, because if we delay any of the tasks, it will impact the minimum completion time there of 83 minutes. Okay, the last question here says, what effect will reducing task D by 3 minutes have on the critical path or paths and overall completion time for this network? So if task D here now is no longer 12 minutes, it's now 9 minutes. How does that impact the critical paths and the overall completion time for this network? Well, what you'll notice now is that 22 take 9 is obviously no longer 10, it's 13. So because the earliest start time and the latest start time at this node are now different, C and D are now no longer on the critical path. So the first thing, there will now only be one critical path, okay, which is along A, B, E, H, and L. And the other thing, obviously, because there is already a critical path there shown in yellow, we reduce task D by 3 minutes. It doesn't actually impact the minimum completion time, all right, or the overall completion time. So the overall completion time remains 83 minutes. Okay, and that's it. That's the question. It is a tough question. Yeah, I guess the complexity there is that, yeah, the network's drawn, the forward and backward scan's done, but those individual times aren't given. So that's it. Hopefully that helps, and all the best with your study, guys.